Well, thanks for coming, everybody. How many Australians are here? Excellent. And how many of them are not Googlers? How many not Googlers here? That's a lot too. It's good to see there's still somebody we haven't hired. People from the real world. Myself, a bit of background on myself. I started Linux development in 1999, which makes me a newbie because people join a kernel project never seem to leave. I started out doing some maintenance work on network drivers, and then in the year 2000 I spent pretty much the whole time just fixing bugs in the 2.3 series. I would lurk on the mailing list, try and reproduce other people's bugs, work with reporters attempting to fix bugs. And so whenever a young fella comes up to me and says, how do I get into kernel development? I tell them, just fix bugs, because it's a great way to learn the code. I found that you could stare at code for days and days, stare at it until your teeth fell out. You'd never learn it as well as when you needed to get in there and make a change. So I always tell people that. None of them ever do it. Around about 2001, I got a job doing Linux stuff. I was porting the Red Hat's 2.2 based ext3 into the 2.4 kernel. And file systems and memory management are terribly closely linked in Linux, so that inevitably I learned a lot about memory management that way. So when the 2.5 series opened up, I did a lot of work on memory management, managed to fix a lot of the problems I had wrestled with when doing the ext3 port. Then Linus came along and tapped me on the shoulder and asked me to look after the 2.6 series after he had branched off 2.7. Of course, we then changed the plans, so we have no plans now ever to open a 2.7 series. So basically, Linus and I are co-maintaining, if you like, the production kernel, which is also the development kernel, the 2.6 series. And that situation has been relatively stable for the past 3 or 4 years now. My talk today is what Leslie politely called a reprise of a talk that I gave earlier on this year. So if any of you were in Belgium and heard me speak in February, you can go away now. But it's surprising that when I was doing my reprise of the reprise, how much stuff had changed just in that 2-month window. Quite a lot of things I say, nope, not going to do that. And a lot of new things came in. So kernel development is pretty rapid. And the rate of change of code is very fast. And a lot of new things come up very commonly and very rapidly. So the sort of things I was going to look at today, and I've got about 40 minutes of stand and deliver here, I think, and probably 20 minutes of Q&A at the end. It's important to understand my job in the world is to serve people such as yourselves. So it's probably more beneficial if you were all standing up here and I was sitting down there and you're talking to me, because it's important to me to understand what people are using Linux for, what their pain points are, etc. So please, let's use that 20 minutes, which I'm happy to arbitrarily stretch, so to help me understand how we're going in the kernel and whether we're going in the right direction, etc. In my prepared material, I have some stuff on which features have recently been merged in the kernel, which features we're presently contemplating, and what might turn up in the kernel over the next 12 months or so. I'll spend some time looking at who is actually developing those features and what their motivations are for doing kernel development work. I'll look at what the role of professional developers is, people who are paid to work on the kernel, versus those who do it out of love or stupidity. And we'll also look at the private developers and I'll also touch on how individuals who are not paid to work on the kernel but who wish to contribute to the kernel, how they could most effectively do so. First up, what sort of machines use Linux? It's a pretty sophisticated audience here. This is probably not really news to you. I like to break it down into 4 main classes of machine. The servers and the other large machines, which obviously do database, web file, and all the other sort of servicing which goes on. A lot of attention to scientific computing machines, the really big number crunchers, which are very predominantly IA64 based nowadays. And most of the funding for kernel development is still comes from companies who are interested in markets which use Linux as a server. So it's from the server market. And that includes the hardware companies. Intel, I think, is most prominent nowadays. The software companies whose customers use Linux, that includes not only the distros, obviously Red Hat and SUSE are great kernel developers, but I'd also in that categorize companies such as Oracle, IBM, who have motivation to have Linux working as well as possible on their customers' machines. And we on the kernel team always get blamed of being excessively focused on the server side of things. It's not true. We're only excessively funded by the server side of things. Moving down the stack, the desktop machines. I believe it's less commercially important to major players in kernel space. But to us who actually work on the kernel, I mean, we all run Linux on the desktop, and most of the people who very freely email us are also desktop users. So desktop gets a very high level of attention, even though it's not as commercially significant as the server space. Consumer, or what you might like to call large embedded, well, I think of consumer machines, they often tend to be x86. So they're basically a glorified PC with various bits taken off. Such as instrument control systems, the digital video recorders, and the PlayStation 3, etc. So big embedded systems, if you like. The amount of funding which the kernel development gets from companies who are in this space is, I think, disproportionately small. That's because I think people in the consumer space are afflicted by what I will call the embedded problem, which is about 3 charts ahead. The fourth category I look at is embedded. A lot of smaller devices. I've listed some here: cell phones, PDAs, your little wireless routers. Televisions. I discovered the other day that I think every digital television that comes out of Asia now is Linux-based. All of them, Panasonic, Sony, Samsung, all of those. So I discovered my new flat screen television is a Linux box, and I didn't know. I impressed my kids. It works. Camcorders. A lot of little camcorders nowadays are running Linux. A very old version of Linux, but they're running Linux. And the handhelds. These tend to be not actually from the manufacturers, it's people who've grabbed a handheld and then ripped out whatever was on it and put Linux in it. The very smallest devices which run software, I think things like television or remote controls and the garage door openers run software, I don't know. But those things are not addressed by Linux. They tend to be much more specialized, and I think Linux is always going to be too heavyweight to get into the very smallest embedded devices. Most of these embedded systems, they're usually non-x86. They often use a very cheap microprocessor which doesn't even have a memory management unit in it. And they generally won't have a rotating disk. Of course, a lot of them will have a flash disk. The amount of funding which we on the kernel team get from companies who are doing embedded development is disproportionately small. And maybe it was 4 charts ahead, but we'll get onto that. And looking at what companies' motivations are to fund development of the Linux kernel, I think there are 3 main categories here. They are the hardware companies, the people who actually sell adapters, motherboards, all that sort of thing, which their customers wish to run Linux on, and obviously they want Linux to run as well as possible on their hardware. There are the software vendors, the IBMs, the Oracles, the Red Hats and all the rest, who sell software and services to those customers who want to run Linux. And there are the device manufacturers. These are the people who are going to put a product out the door that has Linux in it, but the customers generally won't even see it. I view a critical difference between these groups here is that the hardware and software vendors, their customers have an expectation that they will be upgrading the kernel version across the lifetime. And we all know we've gone from Fedora Core 5 to Fedora Core 6 or RHEL 4 to RHEL 5, etc. The customers expect to have to do that, and their providers expect them to have to do that. And I think this is a critical difference that reflects back on the funding situation. These companies have worked out if they want to get new features into their customers' kernels, new hardware support, new optimization features, etc., Turns out, finally, after many years, everybody's worked out the best way to get new features into end customers' hands is via the kernel.org kernel. Used to be the case back in the 2.4 days for a number of reasons. A lot of companies would just get their drivers straight into the Red Hat kernel, straight into the SUSE kernel, and they had no real route up into mainline. That all changed. Things nowadays, people are much better, and many companies are much better working against mainline. And this has been aided by some policy changes at the major vendors, particularly Red Hat nowadays. Have a strong tendency if a hardware vendor comes up to them and says, look at our driver, they'll say, no, send it to Andrew, send it to Linus, send it to James. And everybody's being very good about that. I think the overhaul, both quality and consistency of the kernel has benefited from that process. And the fact that people have worked out the best way to deliver features to their customers via kernel.org, that has helped us get funding for the kernel development, mainly in the form of salaries. Now, some of the device manufacturers, not all of them, they also have upgrade plans. For example, PS3, that I expect they'll plan on revving their kernel sometime in the future. The company I previously worked for, Digio, who make personal video recorders, also they up-rev their kernel version during development to pick up the new features which are coming out of kernel.org. Whereas for embedded companies, I think the critical difference with an embedded company is once they ship the product, they have absolutely no plan whatsoever to up-rev the kernel. So if you're making a camcorder, you'll go off and grab a 2.4.18 kernel or something perfectly ancient like that, customize it, ship it, and you'll never upgrade that kernel. So because you have no plan to upgrade the kernel on your device, you really have very little motivation to get your features, your changes fed back through the kernel.org kernel. And one of the main reasons people do that is cost optimization, so they don't have to permanently maintain the patches and retest them every time. You dump it on Linus and Co, and they'll look after it for you. But that argument doesn't apply if you never intend to take that kernel back down from kernel.org. Other reasons why we see relatively little funding from the embedded side of the world is it's a hard Scrabble life. The time to market is extremely short, and there's not a lot of money in it. We do obviously see some involvement from embedded companies, and I think a lot of that comes not from the people who actually ship the products, as much as the people who ship components to them. So, for example, ARM, they don't make embedded products, but they have commercial motivation, have Linux run as well as possible on ARM-based machines, so they can pick up as many device manufacturers using Linux as possible. So ARM do, as an example, do fund Linux development for that reason. So despite the fact that embedded is underrepresented in the kernel development community, we all think it's cool that so many devices out there, all the cell phones and television sets are running Linux. And so even though a lot of the people who work on the kernel, they're not really funded to make embedded better, we do care about the quality of embedded support, and we always review those big server patches with an eye on what is the impact of this on embedded. Will it hurt all our other users? Switching topics now. This is basically a very partial overview of some of the things which are happening in the kernel development at present. What I think is going to happen soon, who's doing it, why they're doing it, and other stuff. It's always hard for me to predict what's going to be in the kernel in 6 or 12 months' time. I have no staff. I don't have a quarterly planning meeting where we sit down and work out what features we're going to develop over the next 12 months and assign heads to them. And so all I can say is what I see other people working on, the people who do have engineers working for them. I find out on the grapevine what they're working on, and so my prediction is just based on what other people tell me they plan to work on. On the server side, InfiniBand is huge. There have been a lot of changes going in, and a large amount of changes continue to flow through. There's been a surprising amount of work happening on core networking. New protocols which I never knew existed are appearing in the stack, and a lot of refactoring and restructuring of the network code base goes on. New implementations of TCP flow control, entire new protocols sitting at the IP, on top of IP, etc. Storage, I think most of the activity at present is in serial ATA. SCSI, in some ways, is a bit stalled because of the sheer complexity of the SCSI stack having to support so many old, crufty old hardware and crufty old drivers that sit on top of them. And when we look at things like serial attached storage, people are seriously considering bypassing the SCSI stack to a large extent to avoid all of that legacy. Tremendous amount of work happening in NUMA over the past 2 or 3 years. That's very much been driven by SGI, who recently, I believe, booted Linux on a 4096 CPU machine. But the nice thing about the work which SGI is doing to improve NUMA is that it's also beneficial for the Opteron machines, the Opteron machines, which are also NUMA. And it tends to be the case that a NUMA advancement, if it's a good one, will also help scalability and performance on a boring old multi-core or symmetrical multiprocessing machine. Virtualization. Obviously, there's the great war between Xen and VMware, which has been going on for about 3 years, and the war between Xen and the kernel team, and the war between everybody and everybody else. And up comes KVM, and they got in first. KVM came out of nowhere, well, Israel actually, but metaphorically nowhere, and was an easy merge. VMware support it appeared in 2621. Which was released a week ago. I expect support for Xen Domain U will be in 2622, although it's being a bit of a difficult birth at present. And of course, Rusty Russell decided none of that was any good and went off and wrote his own implementation of both the hypervisor from it's Linux on Linux, so he has a very simple client host side and guest side. And no versioning between or anything, so if you try and run a 2620 guest on a 2621 host, it won't work. But it's basically, lguest is supposed to be a minimal skeleton, how to do it code, easy to hack on. And I'd expect lguest will appear in 2622. Tremendous work going on in containerization. This is a very difficult topic because it means so many things to so many different people. You have the vServer, the virtual server type people who want to take a single machine and partition that up against a couple of hundred different customers who want to all run their own version of Apache and not stomp on everybody else's version of Apache. On the other hand, you have the enterprise guys who want to have resource management. So you can have your backup suddenly fires off and you don't want it to cause excessive latency from your database query engine. So you want to be able to partition machine and avoid interaction between different jobs running on the same machine. So that's resource management. Other groups of people, apparently there's some tie-in between containerization and high availability, which I've never understood. I think partially it could be to do with migrating jobs from one machine to the other. So a whole bunch of people with different requirements, all of which fall under the category of containerization. And the requirements are a little bit different, their implementations are a bit different, and a lot of them have gone a long way down the track of having implementations. I mean, the OpenVZ guys, they've been shipping the product to many customers. I mean, they've got hundreds of thousands of machines out there running OpenVZ. So their ability to accept the changes which other stakeholders are going to force on them is pretty limited, because they obviously, when most of their code gets in the kernel.org, they want it to be reasonably compatible with what they're already shipping. So we've been dancing around the containerization issue for a couple of years. We are converging. I think most of the stakeholders are playing together quite nicely, but it's a complex problem. Some of the bits and pieces have gone into the tree, mainly in terms of virtualization of particular global resources within the kernel. And right now, everybody seems pretty happy with Paul Menage's patches. Paul's at Google. He's done some work on this. And unless somebody makes serious objections to that approach, I expect we'll be going down that track using Paul's stuff and then let everybody else build on top of that. Resource management, I touched on before. This is the ability to not have one job running the machine trash another one. It gives some degree of quality of service between different unrelated jobs. IBM for many years was pushing CKRM, the class-based kernel resource manager, and that went through many generations, each one about half the size of the previous one, in response to what we politely call feedback, to reach the stage where it was actually quite a sane-looking patch set. But now, most of the developers, they're all slotting in behind the containerization effort, which will pretty much meet their requirements if and when we ever get there. Kexec and kdump. Kdump is an important enterprise feature. It's the ability to generate a kernel crash dump. Your kernel goes, oops, it'll go and sputter its guts on the hard disk so that we can then pick up the result after the reboot and analyze why the kernel crashed. There have been numerous implementations of this done out of tree. All of them involved the crashed kernel writing a copy of itself to the network or to disk. That was generally never acceptable to us. Linus always thought it was stupid. You have a kernel which is already toast. To attempt to get that to write to disk is a very dangerous thing. So we took a new approach, and it was completely vaporware, but we decided to do this 2 years ago at Kernel Summit in Ottawa, to use kexec instead. Kexec is the ability for Linux to load a new copy of the kernel into itself and jump to it, so you can basically do a reboot in a fraction of a second. The way we modified kexec was that once you jumped into this new kernel, we would leave the old kernel alone, not touch that memory. And then in the new kernel, we have a little /dev node which you can access all the old kernel's memory. So the kernel will crash, we'll then jump into the preloaded new kernel, and then the new kernel, which comes up fresh, clean, hasn't trashed its data structures, that kernel will then write the crashed kernel to disk or across the network. And that's been merged. A lot of people are working on it, and the various vendors, enterprise people are slowly slotting behind it. My secret plan with kdump is I would very much like we developers on the kernel team to be able to get a crash image from people whose kernel has gone tits up. Because at present all you get is an oops trace, and it's always word wrapped. And you don't have the symbol table. It's very hard to work out exactly what line you crashed on, etc. So it would be lovely one day when someone's kernel crashed, they can say, oh, it crashed, and by the way, here is my crash dump. So you can then fire it up in GDB and have a look at the data structures. So I view kdump, even though it's an enterprise feature, could be quite useful for the general kernel development effort. And no, I'm not interested in people's page cache. I don't want to see your password files and whatever else you have in memory. So we expect kdump will not dump that part of memory, which is the great bulk of memory. We're not interested in user data. We're only interested in kernel data. Kprobes, that's the ability effectively of a kernel module to set a trap point somewhere in the kernel. And main reason for that is for advanced instrumentation. It's supposedly our answer to the Solaris dtrace feature. SystemTap is the user space component of that, and it's supported by Red Hat and various other vendors. The way it works is you write a little script in a funny C-like programming language, and you feed that into SystemTap tools, which then will turn it into a kernel module, load that module into your kernel, and then it will hook itself into the core kernel by inserting trap points using the kprobes facility. And then we have high bandwidth interfaces coming out of that module to user space. So if you want to get in and say, I want to trace context switches, or I want to trace disk I/O, or I want to trace this particular line, you can do so, all in this programming language which SystemTap provides, and I think it has pretty graphical user interfaces and things as well. Difficult project, but the vendors seem committed to it. It seems to be going fairly well. ext4. I think file systems generally is slowly turning into a weak spot for Linux. ext3 is a bit slow, a bit ugly, has limits on device sizes, and it's just generally not particularly 21st century technology. ext4 is, well, XFS I think is generally a better file system. It's creepy how well XFS can do file layout. For the high-end machines, it is extremely good. There have been various times when we found problems with ext3 where somebody tosses a really twirly workload at it and it does really bad stuff. I think, aha, I bet XFS can't do this, and damn, it does, every time. So a lot of work has gone into XFS. It's fiendishly complex and nobody understands it. Unfortunately, the vendors, for which we mean principally Red Hat and SUSE, seem very reluctant to support XFS. I think the reasons for this are they don't have any engineers who can understand it, and the attractive thing about ext3 is that it is understood and supported by engineers from a lot of different companies. So as far as I can tell, the vendors have decided to hook up behind ext4 rather than investing in XFS. ext4 has all the new features, extent-based allocation. It will have delayed allocation, large device support, etc. I don't think there's any reason for thinking it would be a lot faster than ext3 in a lot of cases, but it basically, for certain easy workloads and for large devices, it will fill the gap. But I suspect we'll still have significant performance problems with significant workloads on ext4. Basically, I think we need a new file system, and I just don't know where it's going to come from. Large S&P, multi-core, people. Yes, Daniel? ZFS. ZFS. I could talk about Sun at length if you like. Well, ZFS is license is incompatible, so one would have to start again. Things we're doing for desktop machines. Hot pluggability, or, well, actually it's sort of hot plug then crashability. Hot plugging of CPUs, nodes and memory is not a desktop feature. That should have been on the previous chart, which I apologise. Hot pluggability obviously is mainly things like car bus devices, Firewire devices and USB devices. A lot of work going on power management. We're still pretty stupid about power management. We really support only 2 states, that's off and on. I expect one day more pressure will come upon the operating system community to have smarter states than that. Like if my network card hasn't sent any packets for the past 10 milliseconds, well, why is it still fully powered up? But I really haven't seen any threat that we're going to have to do that yet, but I expect it'll happen one day. Just putting devices into a lower power state, which is not off. We don't have much infrastructure support for that. We're having trouble getting off and on working. It's always the BIOS's fault, it's never our fault. Frame buffer drivers. It's one of those subsystems I know nothing about. It just enormous amount of activity coming out of the new drivers, a lot of maintenance work and fix-up happening there. We have a wonderful maintainer, Tony Daplaz, who is a physician living in the Philippines, who has no interest in working for a Linux company, just seems to spend all his time ignoring his patients and working on frame buffer drivers. He's great. Direct rendering drivers, this is the 3D stuff. Obviously all sorts of problems in this area to do with lack of specifications and certain closed source drivers from certain companies. But again, a great maintainer there, David Airley, who's of course in Australia, doing a tremendous amount of work there. The input system, a whole plethora of input devices, popular source of crashes and hangs and things like that. But again, a lot of development there, strong maintainer. Sound is taken care of by a couple of SUSE engineers with the ALSA stack. USB's got about 1,000 different developers, each one with about 1,000 devices to take care of. 1394, the old FireWire stack. This has been a problem child for a long time. It used to be a long time that running FireWire on SMP was a good way to reboot your machine. But Stefan's done a lot of sterling work there, and a new FireWire stack, I think complete new FireWire stack, was sent to Linus for merging today, but I haven't checked whether he actually merged it. So the plan there is to take the new FireWire stack, build it up to the same level of functionality as the older one, and then throw the old one away. And even though the kernel API is a bit different, they assure me that everybody uses the user space library and will be API compatible at that level. So if you are programming directly to the system call API, sorry. You should have used the library anyway. A lot of our work with the desktop concerns latency. This is what I call the squeaky wheel problem, where people who notice oh, that was a 100 millisecond glitch, I need to email Ingo and Andrew and everybody else about my 100 millisecond glitch. So we have a lot of squeaky gates and on the mailing list, and so a lot of work happens. This is people who complain a lot. Squeaky gate gets the oil. So a lot of work is happening with interactivity. Now I must admit, I had a report the other day that a guy's machine went to lunch for 20 minutes, so he had a right to squeak. But not all of our interactivity problems are that bad. But we continue to work on the interactivity, and this is in three main areas. The I/O scheduling, generally the prioritization of reads versus writes on the disk. Our dirty memory write-out policy, which right now I politely say is optimized for performance rather than latency. And the CPU scheduler, which everybody always seems to have an opinion about, even if they don't have their own version of a CPU scheduler. Dirty memory write-out is, I think, probably our biggest problem. There are certain situations in which the kernel will perform very badly. It doesn't just affect desktop machines. It can also be a quality of service issue for server class machines. Several people are working on that from totally different directions, and none of them have quite got it right yet. It's a tough problem. The other thing, when people say, oh, you don't care about the desktop, I'll tell them, well, we put in iNotify. We haven't actually done any work on iNotify or fNotify for the past year or so, but it's a fancy way in which the kernel can deliver notification to user space that a file has changed or been added or deleted or read from, so that you can update it in your little GUI window. A few technologies going in that are more targeted at the smaller machines, consumer and embedded. The ones we merged into 2620, of course, are the dynamic ticks and high-res timers. I used to work with an old AIX guy whose jaw hit the floor when he found out that Linux is still doing an interrupt every 10 milliseconds. He said, why you do that if there's nothing to do? Well, it's hard. But it was hard. But now we do have dynamic ticks, which works on some machines, but it's very good at falling back to the old scheme if it doesn't work out. And it will basically, the whole machine will go to sleep. If there's nothing to do for another 1.1 seconds, the whole machine will just go to sleep and won't wake up for 1.1 seconds, rather than waking up every 10 milliseconds. And leverage on the back of that, because we are now instead of programming a timer to go every 10 milliseconds, we program it to go off exactly when we need it. This gives us much higher resolution timers than we previously had. So we've gone from a 10 millisecond resolution down to something pretty arbitrary, depending on what your clock card oil support. The people who are really crying out for this were the one laptop per child who do not want to wake their machine up every 10 milliseconds. And it's a significant power saving for the OLPC. But a lot of embedded systems with really aggressive power requirements do like that feature. 2.6 kernel, I think, has got fatter. I think the smallest build you can do on a tiny little uniprocessor machine is still a bit larger than 2.4 kernel. We are concerned about it. We do continually try to counteract it, but these things happen. It's been a very slow growth. One thing we put in recently, finally, was the ability to just make the whole block layer go away, the entire support for block devices and buffer heads and disk I/O and all that sort of stuff. You can just disappear that completely from your kernel build if you do not have disks in the system. No MMU support. Support for MMU-less machines is being maintained mainly by Dave Howes at Red Hat, and as far as I know, that's working well. Funny little CPU architectures keep on turning up. FRV, AVR32 from, I forget who that's from. Blackfin comes from Atmel, that will be in 2622. A number of these are no MMU, and some of them are either no MMU or MMU. Various bus technologies and I/O technologies such as AMAP and SPI are being actively maintained by people who are also working in the embedded area. Very important to embedded is Ingo Molnar's real-time tree, which is a separate patch set from the kernel which contains all sorts of features, and apparently it does real-time, hard real-time very well. There have been a lot of technologies that have been available out of tree, you know, add-on monster patches or little operating systems which run underneath Linux and use Linux as one of their applications. But I think a lot of those are sort of falling by the wayside now as these serious real-time vendors are actually shipping Ingo's tree, and as we're gradually moving features out of Ingo's tree into the mainline kernel. A lot of things have come across from Ingo's tree. It's sort of a testing ground. And I'd imagine at the end of the day, if we can merge things faster than he can write them, we'll actually get most of the real-time tree into the mainstream kernel. The one feature which we may have a little bit of trouble putting in is, one feature Ingo has is all the interrupt handlers for all the devices actually run within task context. So he'll take an interrupt and he'll just basically poke a task, and then the task will run the interrupt handler rather than running it synchronously within the interrupt. That's the sort of thing where Linus says, no, we'll never do that. But when we see the patch, we'll probably end up doing that. Well, he said that about SMP. We'll never support SMP. So Ingo's pretty good at these things. I'd imagine when he finally gets down and presents the patch to us, we'll say, oh, that's not so bad. Instrumentation, I think this is a weak spot in the kernel, particularly for the sophisticated enterprise side of things, people who really want to know what's going on inside their kernel. I don't think we expose enough stuff to the sophisticated programmers to help them understand what the kernel's doing to them and why it's doing it. Features are going in at a steady pace, if not a high pace. We recently put in per task statistics called task stats. That was a fairly major change. What task stats does, it'll basically, when a task exits, it'll grab a little packet of information, about 30, 40 fields, about how much runtime it did and all sorts of things like that, and deliver that across the netlink socket connection up to a daemon which is monitoring. Task stats was designed to be very scalable for the high-end machines. The important thing about task stats, it is now our future way of delivering per task instrumentation out to applications. And already one fine programmer, namely myself, added per task accounting for I/O into task stats. So I was able to just stick a few more fields on the end, so when a task exits, you can find out how many bytes of I/O it caused to be read and written. And that was very easy to do. Also, task stats, you don't have to wait for the task to exit. You can actually query a presently running task and get its counters out of it, so for ongoing monitoring. One other thing we're working on is per process memory footprint monitoring. That's a fine term, isn't it? It's very difficult. People want to say, well, how much memory is my process using? It's been running 24 hours. I can see the resident set size is 1.5 gigabytes. Well, how much is it really using? Well, search me. We don't have any way of knowing. So we had a little brainwave here. What we do is we go into the kernel, and for every page which that process owns, we'll just go and clear all the reference bits within the page table entries. So now, as soon as you've done that, you can then go into the process and count up how many reference bits are set. So immediately after you clear them all, you expect none to be set. But as your process goes off and touches pages, you'd expect to see the number of reference bits go up across time. So the programmer, the system administrator, can then get some idea of how much memory his process is really using, rather than how much it actually has allocated. So that was good. That product, in fact, was brought to you by Google. But now Matt McCall has gone totally turned that upside down and has developed new interfaces for the kernel which let you get access to every single page frame within your process to find out whether your page is referenced, whether it's dirty, what sort of page it is, etc. Very low level interface. Might change at any time in the future as we change kernel internals, but I think anybody who's sophisticated enough to use this interface will be able to cope with that. But it's something we've always lacked. You have to do quite a lot of user space development to be able to use these interfaces. You need quite a lot of knowledge, but it should give great transparency into both the static and dynamic memory behavior of applications. perfmon. There was once upon a time a thing called perf counter, which gave us access to your processor CPU counters, the ones which Intel and AMD and IBM, etc. give us. Perf counter died, and now perfmon is the way ahead. It basically does the same thing. It's already implemented in the mainstream kernel for IA64. Tremendously large patch, which then gives us access to all of the, or hopefully most of the advanced performance counters on certainly AMD, Intel, Power, and I think several other architectures of various states of support. But perfmon is taking a hell of a long time to get into the mainstream kernel. We had a decent round of review about 6 months ago and things went quiet. But we will get there eventually. But it'll be a pretty important interface for people measuring, getting detailed information about the behavior of their applications. Things happening in the kernel core. K-event. This comes from a gentleman in Russia somewhere who came up with a scheme for anything which can generate an event in the kernel. And when you go through the list, there's an awful lot. There's TTY-IO and file completion and socket completion and timers going off, all sorts of things. Had a unified scheme where the kernel would place a description of the event directly into a user space ring buffer and send a wake up to the application which is waiting for it. So it's basically for your threaded servers, where you can have a whole bunch of tasks all waiting on the one ring buffer. They pick up an event, run away, handle it, come back, wait for the next one. So K-event, I think it reached version number 47 when he started to get a bit dispirited. We never quite got over the hump. I was never to find quite enough people who actually sit down and spend the time to review it. I couldn't get, it's a major interface, very important thing. I couldn't quite get enough mind share behind it. So then along comes Zach Brown from Oracle and proposes something completely different. Rather than having new event reporting interfaces, how about we just make all system calls asynchronous? So if instead take a read from disk, what you'd like to do is say, start the read now and tell me when it's finished. That requires new infrastructure to be put around the read system call. But with asynchronous system calls, what you can do is say, run some arbitrary system call that happens to be read and tell me when that's finished. So theoretically, every system call in the kernel becomes asynchronous. And this basically solves the whole problem because you can take all these old synchronous system calls and not have to wait on them. So it's a nice idea. So Zach came out with this, and that got Ingo coding for about 15 minutes, which he came out with a massive patch set which did it in a completely different way. Ingo called his version of that syslets. It's gone quiet at present because he's disappeared into the CPU scheduler black hole for a few weeks, but I'd imagine that when he comes out of that black hole, we'll start looking at syslets again. And it was looking pretty positive. It wouldn't surprise me if maybe towards the end of the year we do have some asynchronous system call implementation in the kernel. Futexes, that's the kernel's basic synchronization primitive, which allows you to implement user space locking, in which you don't enter the kernel at all in a non-contended common case. Lots of things happening here. We recently merged an implementation to basically a simpler version of futexes, which didn't have to support sharing between different heavyweight processors. So that's an optimization, and I'd imagine that, well, I'm planning on merging that under 2622. People are working on 64-bit futexes. I've got priority inheritance on futexes as well. A lot of work happening there. And it's all well supported by the glibc guys, who, to a large extent, driving the changes in Futex. Adding a new mode to Advise is not exactly a world-shattering thing, but it's a really example of the little incremental changes we make in the kernel to attempt to improve the situation in user space. There are some performance issues with malloc in glibc, which is a function that gets used quite a lot. So we've been working that with the glibc developers, and now there's an implementation in my tree of a new mode to Advise, which malloc library can use to optimize its internal functions. Plan to get that into 2.6.22 as well. David Lebesny came out of nowhere and buried me in patches, which is an alternative to K-event, in which we've got these various objects in the kernel which generate asynchronous events to, in instance here, are signals and timer expiry, but there's no way you can select on them. So if you've got an application which wants to either wait on a select on a socket or on this timer going off or on the signal coming off, you end up having to do a signal-based implementation, which tends to be messy and slow. So what David's come up with is a new sort of file descriptor which will, when a timer goes off, the timer will be delivered to you across the file descriptor. So you can just add that particular special file descriptor to your select set, and it will come up and say, hey, here's a timer for you. And that's looking like 2.6.22 material as well, about 2 months off. Debuggability. It's important to us. We don't all work in the one building and talk to each other from 9 to 5. Kernel developers, kernel testers, they're all spread all around the world. It's very important to us that the kernel have a lot of self-checking, self-consistency checking, and also a lot of infrastructure in there to help the developers who are 12 time zones and 5,000 miles away from the reporters find out what the heck went wrong. Ingo did the locking dependency checker recently. That's a pretty sophisticated thing that will monitor the order in which various types of lock are taken and develop a dependency graph between them. And later on, if it sees some locks being taken in a different order, with incorrect dependency, we'll report on it. So you have a potential deadlock here. I recently merged a framework for deliberate injection of faults. So you can, if you're designing a device driver, you can wire it up to this library and deliberately poke faults in your device driver to simulate memory allocation errors or checksum errors or anything like that. Nobody's using that yet. Kernel debuggers, everybody thinks we'll never have a debugger in the kernel because Linus said no. I think I can talk him around. My preferred option there is KGDB. The only other options on the table really are KDB, which I think is too low level. It doesn't understand source code. And the Novell debugger, which the patch is pretty scary looking. KGDB, I would have merged it years ago if it really had somebody who's prepared to stand up behind it and support it long term. But nobody's really been on offer yet. However, there have been some changes recently which are optimistic looking. I could get KGDB back in my tree within a month or two, I hope. It might be on the way to mainline. Cleanups, they drive everybody wild. People go in and they make functions static and they fix up your white space and they take out your includes and they add new includes. Everybody hates it. But, and it does, sometimes it breaks things. Sometimes I get nasty grams from developers saying, hey, you broke my code. But we grit our teeth and bear it because we do expect the Linux kernel code base, I mean, when are we finally going to delete it? Probably well after my career is over. It's going to be there for a long, 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 long time. We understand we're in it for the long term. The clarity and maintainability of the kernel is an important asset. So even though there are short-term costs, we do believe all these cleanups are of long-term benefit. And certainly when you go back and look at the 2.4 tree, you say, yuck, did we do that? Things have got a lot better. So, yeah, we merge them. We hate it, but we merge them because we feel we need to do so. Things I don't know about yet. People just pop out of the woodwork with features which I never expected. K-event was one case there. KVM, of course, is the classic from the last year. People just have a brainwave and come up with something, and sometimes it's somebody you've never heard of. The curious thing about KVM was that it came from a bunch of people we'd never heard of, but it was very clean and very idiomatic kernel code. It looked like the guys had been working in kernel land for years, but it was, as far as I know, their first submission. It was such an easy merge, so it was a pleasant surprise. Kernel contributors. The great majority of kernel work now is done by people who are paid for it. Most of them deserve to be paid for it, but not all. But the private contributors are still important. They're not as important as they were 10 years ago, I don't think. But, and they're particularly important in desktop-related development because they're doing things, because they're mainly desktop users and they're doing things which matter to them. And oftentimes you get somebody who's a contributor and you don't know who they work for. They may hide behind some email address and you find out, oh, I've been working for Intel for 5 years. Oh, have you? And as I say, a lot of these people, if they're any good, they don't stay individual contributors for very long. People tend to snap them up. The area where non-professional contributors best contribute is, of course, in testing. There are lots of crazy people who will download the latest snapshot kernels, the latest release kernels, and even the latest kernels, the one I inflict on the public, and just test it, find out what any problems are, and report on them. These people are indispensable to kernel effort. If these people didn't download and test development kernels, the whole project would grind to a halt. I don't exaggerate that. Reason being, I mean, you've got a core of 100 or 200 kernel developers, which means they've got a core of 500 or 600 machines to test kernels on. That's those of them who do actually test stuff. But that's only such a tiny subset of machines we actually need to run on. So people will get their code and test it beautifully. I mean, I used to allegedly still maintain the 3Com network driver. I only had a stack of NICs this high. The driver is supposed to support 23 of them. And then you get interactions with various PCI issues, interactions with ACPI, Wake on LAN. The number of combinations is awful. So we're very much dependent on the external testers because they have different hardware from what the developers have and because they'll toss different workloads at it. It seems that a lot of our useful testers are guys who are like working at an ISP and he's supposed to be looking after his customers. Instead, he's loading the latest kernel on his production machines. I'm not complaining. I'm glad that don't work for me. A lot of them quite sophisticated users and they're just great and can't thank them too much. But if you're one of those fine people who want to help contribute to the kernel effort, testing is an easy and extremely valuable way of doing so. So this is my ask not what the kernel can do for you, but what you can do for the kernel slide. How to test the Linux kernel. If you're brave enough to compile your own kernel, you'll grab the latest snapshot from the snapshots directory on kernel.org, and I think it's linked off the front page, and just use it. People say, oh, should I run Benchmark? Should I run Bonnie? Should I do that? I don't think so. I think it's valuable if people just use the kernel in their day-to-day use. If it works okay, fine. If everybody does that and it works okay for them, we're done. So nothing special needs to be done. Testing, probably, I think, once a week or once a month is a suitable interval to update your kernel and keep an eye out for things which are going wrong. Fedora, OpenSUSE, very nicely, they put out a bleeding edge kernel. I'm not sure about the OpenSUSE one, but the Fedora kernel is generally no more than 1 to 2 weeks behind the kernel.org kernel. Very much in sync with the kernel.org kernel, and we do readily accept bug reports against the latest Fedora kernel. There are almost always also bugs against mainline. And the nice thing about that is you can just grab the RPM, which Dave put up there for you, and install it without having to build the kernel. If it doesn't work, great. If you do have a problem, reporting it is the greatest value. Often developers will then come back and say, well, can you please try this patch or that sort of thing. A lot of people can't do that because they just downloaded the RPM, they're not interested in building their own kernel. That's when we get in a little dialogue with Dave Jones and get him to add the patch so it comes back down via that route. But actually reporting the problem is the main thing. When reporting the problems, the best way to do that, particularly if you're testing a leading edge, a snapshot kernel, some development kernel, report it via email. Be careful about who you send it to. Make sure it goes to the Linux kernel and also to the developers and the relevant mailing list. And if it's a long-term bug, like right now we just released 2.6.21, if you find a bug in 2.6.19 or something like that, it's probably best to go straight to bugzilla.kernel.org to raise the report there. So what I prefer that we do is the short-term hot bug fixes for code which is still in people's mind. Let's do that via email. Generally, we can get it resolved within a day or so. If it looks too hard, if it's been there for a while, I'll push bugs into Bugzilla for longer-term tracking. Those people who have built their own kernels, if we can talk them into it, they will use Git's the source code, the revision control systems bisection feature. So you can actually say, yep, 2.6.21 worked, 2.6.20 worked, 2.6.21 didn't work, and Git, you can then just say, yes, that works, no, that doesn't. Bisect through all the change sets in the kernel until you come down to a particular patch, which is the one which broke your machine. It's wonderful when it works. Sometimes it doesn't work because Git, it doesn't have a linear sequence of patches. It has some complex n-dimensional graph which I've never understood. So Git bisect will sometimes get stuck close to, but not exactly on the buggy patch, but that's still useful news. Chances are it's pointing at an ACPI patch. It normally is. So then we can tell Len, look, one of these 100 patches, yours is broken. You're fine. Put it in Bugzilla. In a couple of years' time, it might be fixed. But if you do get stuck on Git bisect, people can talk you through how to get over the hump and actually get down on a particular change set. So Git bisect has been very useful to us, and a lot of people you've never heard of before will come up and say, I bisected it down to this particular patch and it broke. And that's so good. Bye-bye patch. Or send a nasty gram to the originator. That's it from me. My 40 minutes went for 59 minutes. Questions and answers, please. Thank you. And it's important that you tell me things I need to do, I need to know, rather than having me tell you things you want to know. Yes, sir.
I think you were going to talk about the funding situation with embedded systems.
Didn't I talk about that? The funding situation with embedded systems. Well, that was all my waffle about why they're not motivated. Because they don't have plan to upgrade to a new kernel means they don't work against kernel.org, you see. A lot of people go to various conferences and stand up in front of the embedded people and tell them how to interact with the kernel community, etc. But the message doesn't seem to be getting through very well. They don't have commercial motivation to do so, I'm afraid. Daniel.
ZFS question.
ZFS.
No, currently XFS.
XFS.
Is it perception out there that XFS will be zeros in your file instead of data?
Yes.
The old data on unexpected shutdown.
Yes.
You got any data?
Only anecdotal data. The problem with XFS is, well, there's a long-standing problem with XFS in that you're using XFS, you write to some files, your machine goes, you bring it back up, and that file now has zeros in the middle where you'd expect to see data. The way ext3 gets around that is it writes every time it runs a journal commit, every time it writes out your file's allocation information, it'll write the data first. So it writes the data out, then it writes the metadata which refers to the data. So if you get a crash plus recovery, you don't have metadata referring to data which hasn't been written yet. XFS doesn't do that. It's a metadata-only journaling. So XFS, when you do a write to a file, it'll dirty the page cache, then it will write the metadata to the journal first, and then if you crash, you have metadata in the journal which refers to data which hasn't been written yet. Steve Lord, many years ago, assured me, no, that doesn't happen because of waffle, but it does happen, and people regularly complain about it. Yes. Files will come back with zeros in them on XFS. I think we can fix that. But to do that, I know exactly how to do it. You need to take over the MM tree for me so I get time to do it. I have described how we should do this several times, but nobody's picked up the ball and run with it yet. But we can solve that in the VFS. Simply by doing a sophisticated F data sync before we run the metadata commit. It's basically, it's ordered mode for XFS, but nobody's done it. So,
Do you have any technical comments on ZFS? Because there was discussion about it being dual license and solve a legal issue.
what was that?
So I'm curious if there's any technical comments.
Very little. I don't really have anything useful to say about ZFS. I see people seem to regard it well. It's very un-Linuxy in that obviously Linux separates the concept of volume management and file system growth from the file system itself. We like to keep these things separate, whereas I understand ZFS does a lot of these management roles internally within the file system. That might make sense. I just don't have the experience and knowledge to say. If it really is, if it does come out under a compatible license, yeah, it wouldn't surprise me if somebody got in there and did it. There's one over here. So.
Is there anything going on with the common infrastructure for TCP offload?
Common infrastructure for TCP offload. I don't think I could say anything intelligent about that. I know David Miller traditionally has been very anti-TCP offload, mainly because it does things such as bypassing things which people expect Linux to have, such as net filter and various other packet ingress-egress filtering options. But that's as much as I know. I know David doesn't like it. A lot of people have tried. They haven't managed to get past the David hump. Whether that hump is being smoothed out nowadays, I do not know.
So while we were on the subject of file systems, the other file system that had its big heyday a couple of years ago was RiserFS. What's the story with that? Is it still being developed, or?
Riser 3 is obviously it's kind of mouldering nowadays. It doesn't perform very well, and not a lot of maintenance is going into it. Most of the maintenance that goes into it manages to break it rather than improve it, I'm afraid. But there are a few people who work on Riser 3, but no, it doesn't really seem to have a future. Riser 4 has been in my tree now for about 2 years. Obviously, it has had a few personal problems, which has impacted Riser 4's development. But I'm still getting patches for it. And there are a couple of the namesys engineers from Russia are still working on it. I think sort of on an unfunded basis. And so I wouldn't rule out the possibility of Riser 4 getting merged. It needs a bit more work done into it, needs to get a little bit more mind share and momentum. It had a bad reputation from several years ago where it absolutely had the kitchen sink. Everything was in Riser 4, or was going to be in Riser 4. Well, those plans have been wound back a lot. A lot of code is taken out. It's much more a regular file system than it used to be. So I haven't stuck my nose in there for over a year. But I imagine what we have there is closer to being mergeable than it used to be. But the barrier, there's a pretty high barrier for merging file systems into Linux. There's significant maintenance cost for everybody involved. We need to handle the bug reports. There's the interaction with the VM, which is often complicated and affects the memory management developers. So it's not the sort of thing you can just slot in and think, oh, we'll let them take care of it, because it has impacts on the rest of the kernel and maintenance cost increments on a lot of other people. So we tend to set the bar pretty high for new file systems. And I think this link on the front page, just use it. People say, oh, should I run benchmark, should I run body, should I do this? I don't think so. I think it's valuable if people just use the kernel in their day-to-day use. Works okay, fine. If everybody does that, works okay for them, we're done. Nothing special needs to be done. Testing, probably, I think once a week or once a month, is sort of the interval to update your kernel and keep an eye out for things which are going wrong. Fedora, OpenSUSE, very nicely, they put out a bleeding edge kernel. I'm not sure about the OpenSUSE one, but the Fedora kernel is generally no more than 1 to 2 weeks behind the kernel of old kernel. Very much in sync with the kernel of old kernel, and we do readily accept bug reports against the latest Fedora kernels. They're almost always also bugs against the mainline. And the nice thing about that is you can just grab the RPM, which they put up there for you, and install it without having to build the kernel. If it doesn't work, great. If you do have a problem, reporting it is the greatest value. Often developers will then come back and say, well, can you please try this patch or that sort of thing. Well, people can't do that because they just download the RPM and they're not interested in building their own kernel. That's when we get in a little dialogue with Dave Jones to get him to add the patch so it can back down via that route. But actually reporting the problem is the main thing. When reporting the problems, the best way to do that, particularly if you're testing a leading edge, a snapshot kernel, some development kernel, report it via email. Be careful about who you send it to. Make sure it goes to the Linux kernel and also to the developers and the relevant mailing list. And if it's a long-term bug, like if you, right now, we just released 2.6.21, if you find a bug in 2.6.19 or something like that, it's probably best to go straight to bugzilla.kernel.org to raise the report there. So what we do, what I prefer that we do is the short-term hot bug fixes, the code which is still in people's mind. Let's do that by email. Generally, we can get it resolved within a day or so. If it looks too hard, it's been there for a while, I'll push bugs into Bugzilla for longer-term tracking. Those people who have built their own kernels, if we can talk them into it, they will use Git, but the source code, the revision control system bisection feature. So you can actually say, yep, 2.6.21 worked, 2.6.20 worked, 2.6.21 didn't work, and Git, you can then just say, yes, that works, no, that doesn't. Bisect through all the change sets in the kernel until you come down to a particular patch, which is the one which broke your machine. It's wonderful that it works. Sometimes it doesn't work because Git, it doesn't have a linear sequence of patches. It has some complex n-dimensional graph which I've never understood. So Git bisect will sometimes get stuck close to, but not exactly on the buggy patch, but that's still useful news. Chances are it's pointing at an ACPI patch. Normally it is. So then we can tell Len, look, one of these 100 patches, yours is broken, fine, put it in Bugzilla. In a couple of years' time, I can fix it. But if you do get stuck on Git bisect, people can talk you through how to get over the hump and actually get down and stuff. So Git bisect has been very useful to us, and a lot of people who've never heard of before come and say, I bisected down this particular patch and it broke. That's so good. Bye-bye patch. Send a nasty revision at it. That's it from me. My 40 minutes went for 59 minutes. Questions and answers, please. You tell me things I need to do. I need to know, rather than having me tell you things you want to know. Yes, sir.
I think you were going to talk about the funding situation with the
Didn't I talk about that?
big question.
The funding situation with embedded systems. Well, that was all my waffle about why they're not motivated. Because they don't have time to upgrade to new kernel, and they don't work against kernel at all. So, a lot of people go to various conferences and stand up in front of the embedded people and tell them how to interact with the kernel community, etc. But the message doesn't seem to be getting through very well. They don't have commercial motivation to do so. CFS.
No, probably XFS.
Exit.
The perception out there that XFS will zero CD file instead of data.
Yes.
The old data
Yes.
You got any data?
Only anecdotal data. The problem with XFS is...
Question?
Well, there's a long-standing problem with XFS in that you're using XFS, you write to some files, your machine goes, you bring it back up, and that file now has zeros in the middle where you'd expect to see data. The way ext3 gets around that is it writes every time it runs a journal commit, every time it writes out your file's allocation information, it'll write the data first. So it writes the data out, then it writes the metadata which refers to the data. So if you get a crash plus recovery, you don't have metadata referring to data which hasn't been written yet. XFS doesn't do that. It's a metadata-only journal. So XFS, when you do a write to a file, it'll dirty the page cache, then it will write the metadata to the journal first, and then if you crash, you have metadata in the journal, which refers to data which hasn't been written yet. Steve Waller, many years ago, assured me, no, that doesn't happen because of waffle, but it does happen. People regularly complain about it. Yes. Files will come back to zeros on XFS. I think we can fix that. I know exactly how to do it. You need to take over the NM tree for me so I get time to do it. I've described how we should do this several times, but nobody's picked up the ball and run with it. But we can solve that in the VFS. Simply by doing sophisticated data sync, we run the metadata. That's basically it's all of mode for XFS.
Do you have any technical comments on ZFS? Because there was discussion about it being dual licensed to solve a legal issue.
What was it?
So I'm curious if there's any technical comments.
Very little. I don't really have anything useful to say about ZFS. I see people seem to regard it well. It's very un-Linuxy in that obviously Linux separates the concept of volume management and file system growth from the file system itself. We like to keep these things separate. Well, I understand ZFS does a lot of these management roles internally within the file system. That might make sense. I just don't have the experience on what to say. If it really is, it does come out under a compatible license. It would surprise me something getting there, did it?
Is there anything going on with the common infrastructure for TCP offload?
Common infrastructure for TCP offload. I don't think I can say anything intelligent about that. I know David Miller traditionally has been very anti-TCP offload, mainly because it does things such as bypassing things that people expect Linux to have, such as net filter and various other packet regress filtering options. But that's as much as I know. I know David doesn't like it. A lot of people have tried, they haven't managed to get past the David hump. Whether that hump is being smoothed out nowadays, I do not know.
So while we were on the subject of file systems, the other file system that had its big heyday a couple years ago was RiserFS. What's the story with that? Is it still being developed, or?
Riser 3 is obviously it's kind of mouldering nowadays. It doesn't perform very well, and not a lot of maintenance is going into it. Most of the maintenance that goes into it manages to break it rather than improve it, I'm afraid. But there are a few people who work on Riser 3, but no, it just doesn't seem to have a future. Riser 4 has been in my tree now for about 2 years. Obviously, it has had a few personal problems, which has impacted Riser 4's development. But I'm still getting patches for it. And a couple of namesys engineers from Russia are still working on it. I think sort of on an unfunded basis. And so I wouldn't rule out the possibility of Riser 4 getting merged. There's a bit more work done into it, was to get a little bit more mind share and momentum. It had a bad reputation from 7 years ago when it absolutely had the kitchen sink. Everything was in Riser 4, or was going to be in Riser 4. Those plans have been wound back a lot. A lot of code is taken out. It's a much more regular file system than it used to be. So I haven't stuck my nose in it for over a year. So I imagine what we have there is closer to being mergeable than it used to be. But the barrier, there's a pretty high barrier for merging file systems with Linux. There's significant maintenance costs for everybody involved. We need to handle bug reports. There's the interaction with the VM, which is often complicated and affects the memory management developers. So it's not the sort of thing you can just slot in and think, oh, we'll let them take care of it. Because it has impacts on the rest of the kernel and maintenance cost increments on a lot of other people. So we tend to set the bar pretty high for the costs.
So I've tried to get rid of arbitrary limits in software for a long time. And my favorite arbitrary limit is the command line length limit. And most ordinary users, you can't really explain to them what xcards is all about and train them to use xcards, and then their program will fail sometime when their directory happens to be full of 10,000 files at the worst possible time. Is there any chance we can simply get rid of the command line length limit, or at least have a reasonable size, more like the memory size for a process?
the command line length limit. You know, whenever we reach about 2.6.x.rc6, I've got a problem because my patches directory now blows the command line limit. The stuff I got queued up. It's in that situation now. It drives me up the wall as well. Red Hat says that they just bump the number. So I think the default's 1 meg or 8 meg or something. But Red Hat and SUSE, when they ship kernels, they just opt to. It is a problem, yes. There was a pretty good-looking patch set came from somebody at Google whose name I forget, which would dynamically allocate the whole thing. So they would allocate it. Sorry? No, it wasn't. That's gone quiet in the past couple of months. It's a difficult patch. It involves inserting pages into the new processes NM and getting everything right from that perspective. But unless that person is man enough to actually picks up the ball and runs with it again, or somebody else picks it up, no, I don't see any prospect of that being fixed. It's certainly motivated to do so. Probably work out who that was and give me a kick in the shins actually, because yeah, it is important. What time do you need to go home? Is there any still home? I'll keep going until you get bored.
If you can't answer this question, that's fine. So the word on the street is that Google has their own kernel that they track outside of the mainline kernel. And there's, from what I understand, there's a lot of changes there. I'm curious if you joining Google is actually going to lead to more contributions of Google into the mainline kernel.
I've looked at Google's kernel and all the patches in there which are of interest upstream have gone upstream. So there are various bits and pieces there which are specific. Google worked out that it's to their benefit not to diverge too much from mainline. But they're in a similar situation, I think, for Red Hats and SUSEs and that sort of thing. You've got tens of thousands of developers out there. How do we leverage the best? It's not by picking it up and running away with it. But no, if I see anything go past that looks useful to mainline, I'll just steal it. Send me that patch.
So large projects shouldn't really be written in C, because C is a terrible low-level, buggy, and it's just an awful language, except maybe for a project like the Linux kernel, it's still the right choice. Is there any chance that the Linux kernel would actually use another programming language someday? There was a time actually where it was compilable by C++, right?
Yeah.
I've seen fragments of bash in the kernel. I'm not kidding.
The kernel community as a whole would give you a very emphatic answer to that. With which I disagree. I mean, I spent 5 years doing nothing but C++, and then I went back to working on the kernel, working with C things like eating glass. I hated it. I think you can write excellent in system software, embedded software in C++. You just don't do stupid stuff. We wouldn't use exceptions or anything like that. We would be careful about all the fancy ABTs and that sort of thing. It can be used for tool. That being said, no, I see no prospect at all. No prospect whatsoever. I mean, they even have a variable called int new in a header file. People refuse to take that out. It doesn't compile when I do it in C++. Bad luck. Sorry. No, we'll be doing C forever. I personally, I don't have any objection to make it a bit easier if somebody insists on writing their own kernel module in C++ to be able to accommodate them. There's very low cost for us for doing that, but I didn't stick my head up and say that. A lot of hostility. Right. One more. Yes.
So what do you think about a lot of the move with some of the USB stuff and some other work to allow a lot more driver implementation in user space? Is that something that's continuing to happen, or is that sort of fairly limited today?
It is pretty limited. So there is a framework now which has been proposed for merge, which I don't think mistook it for the user I/O driver. So the idea is, if you have a particular device, and generally it's some particularly specialized device, it's not some mass consumer device, you're a numerical control company or scientific instrument or something. And you have a complicated device, what you'll do is just put a little skeleton into the kernel. It'll map the PCI space for you, it'll handle the interrupt and package the result up and send it up, etc. So The one we have now is about 150 lines. The idea is then the great bulk of your sophisticated implementation will then happen in user space, just talking this little minimal stuff. I don't think, I had some concerns that people would just use it for a license bypass thing, and all of a sudden they've stopped getting decent kernel support. But people convinced me otherwise. It's really only for these specialised people. You don't want to write a massive driver which might include floating point and all sorts of things. You put that on the kernel side. So I think that's as far as we're going to get. Basically, just supporting sophisticated these specialised devices with the minimal stuff in kernel. And the user I/O part is a support framework for those minimal stuff. Does that answer the question?
Yeah, it does.
Right. I see no plan to go beyond the UIO stuff. I don't think that's going to manage it. We're done. Thanks, folks.